Okay, let's dive right into this explainer on Python tuples. If you've been working with Python for a bit, you're probably already super familiar with standard lists. But today, we're totally shifting our focus. We're moving away from those open, easily changeable boxes to a structure that protects your data like a sealed vault. Tuples are a completely fundamental data structure in Python, and let me tell you, mastering their creation, indexing, and immutability, it is going to completely change how you handle critical data in your applications. Here's our quick roadmap for today's explainer. First, we'll meet the immutable tuple. Second, we'll cover creation, indexing, and slicing. Third, we're going to look at tuple packing and unpacking. Fourth, we'll dive into real-world applications. And finally, number 5, we'll uncover those common beginner mistakes so you can avoid the traps. All right, section 1, meet the immutable tuple. Let's really think about what happens when critical data changes. To kick things off, we genuinely need to understand the core problem that tuples were actually designed to solve. Just ask yourself, what actually happens when critical data gets accidentally altered? Imagine you're building a massive database for a mapping app, right? And your highly precise geographic coordinates just get accidentally overwritten by some rogue line of code somewhere else in your program. Your entire application would break. It would literally be a disaster. You absolutely need a way to lock that data down tight. And so that brings us to the crucial point. Tuples provide immutability. By definition, a tuple is a collection of multiple items stored in a single variable that simply cannot be modified after creation. Think of it as a sealed vault. The items inside, well, they can be viewed, they can be accessed, but they absolutely cannot be changed, added to, or removed once that tuple is locked in. This comparison brilliantly illustrates the main difference. A list is mutable, meaning it can be freely modified, and it uses square brackets. It's an open box. A tuple, on the other hand, is immutable, cannot be modified, and uses parentheses. It's a locked vault. That one simple switch from square brackets to parentheses, it changes all the rules of the game. Moving right along to section 2, creation, indexing, and slicing. Let's look at the actual mechanics under the hood. So, how do we actually build one of these locked vaults using simple Python syntax? Creating a tuple is incredibly simple. You just define a variable, here we're using myTuple, and place your items inside parentheses, separated by commas, as you can see with apple, banana, and mango. And the really cool part, you can even mix completely different data types in there. Strings, integers, booleans, you name it, all securely locked together in one place. Now, once your data is secured in the vault, how do you actually look at it? Well, just like lists, tuples use zero-based indexing. Apple sits comfortably at index 0, banana at 1, and mango at 2. But Python also gives you this fantastic, super handy shortcut, negative indexing. An index of -1 pulls the very last item, mango. -2 pulls banana, and so on. It's brilliant because it lets you pull data straight from the end of the vault without even needing to know exactly how many items are stuffed inside. Now let's talk about tuple slicing. Slicing is what allows you to grab a specific chunk of your tuple all at once. You define a start index, you define a stop index, and boom, Python extracts those multiple elements into a brand new tuple. But keep in mind, because of that strict immutability we talked about, this doesn't alter the original tuple at all. It just gives you a perfectly secure copy of the specific range you asked for. 2. Yep, that's the magic number. Because tuples are so strictly locked down, they only have exactly 2 built-in methods. While lists have this massive menu of tools to add, remove, and sort, tuples keep it super lean. They offer count, which simply finds the number of times a specific item appears, and index, which returns the very first position where an item is found. And honestly, this simplicity is a feature and not a bug. It's exactly what keeps tuples incredibly fast and super memory efficient. All right, on to section 3, tuple packing and unpacking. Let's talk about distributing data elegantly. Let's transition to a feature that honestly makes tuples incredibly powerful to work with, packing and unpacking. Packing is just storing multiple standalone values into a single tuple. So we take the name John, the number 25, and the grade A, and pack them all into my_tuple. Simple enough, right? But the real magic, the wow moment, is the inverse. Unpacking lets you extract a single tuple perfectly into multiple distinct variables. Name, age, grade equals myTuple. All of that distributed perfectly in just one single line of code. It is so clean. Section 4, real-world tuple applications. Let's look at why we actually use them out in the wild. Now that you've got the mechanics down, let's deploy this in some real-world scenarios so you can see exactly why this immutable structure is such a big deal. Consider things like geographic coordinates, database records, employee info, core configuration settings, or even constants like the days of the week. Ask yourself, what do all of these have in common? They are pieces of data that should remain strictly, absolutely unchanged. Whenever your app relies on data that must remain constant to function safely, tuples are hands down your best choice to guarantee that security. Let's look at a really concrete example. Think about a simple student record system. You can see here how perfectly a tuple handles mixed data. We've got a name as a string, age as an integer, and grade as a string. John, 20, and A sit perfectly side by side in a single tuple row. Because it's a tuple, you can just confidently pass the student record around your entire application, knowing with 100% certainty that a random function isn't going to accidentally change John's age or magically upgrade his grade to an A+. It is completely safe from accidental overwrites. Finally, Section 5, Common Beginner Tuple Mistakes. Let's make sure you're avoiding the classic traps. To wrap up our technical deep dive today, let's look at the insider secrets and gotchas that literally always trip up beginner programmers. A super subtle but incredibly common trap is creating a tuple with only one item. If you write apple in parentheses without a comma, Python just assumes it's a standard string surrounded by math parentheses. Actually, scratch that. It doesn't just assume, it explicitly treats it as a string. To make it a true, recognized tuple, you absolutely must include that trailing comma. Just one little comma. Don't let that one catch you off guard. It happens to the best of us. And here it is, the ultimate trap, forgetting the golden rule of the sealed vault entirely. If you take a tuple, try to isolate an index like mytuple0, and then try to assign a brand new value to it like orange, Python is going to stop you dead in your tracks. No way. It will immediately throw a type error, stating that the tuple object does not support item assignment. Immutability is strictly enforced here. But honestly, this error is actually your best friend. It's the system working exactly as intended to protect your critical data. Well, we have covered a massive amount of ground today. You now know exactly how to create tuples, how to slice them, pack them, unpack them, and use their immutability to build robust, crash-resistant applications. But I want to leave you with a final thought to ponder. Now that you've mastered protecting ordered data with tuples, it kind of begs the question, how do you handle data when the order absolutely doesn't matter, but every single item needs to be completely unique? What structure efficiently handles completely unique, unordered values? Well, that perfectly sets us up for our next logical step in programming, exploring Python sets. Thanks so much for joining me on this explainer, and keep exploring.